Hi, welcome back. In the previous session, we looked at how we organize the periodic table, or how the periodic table is organized, and we saw that the vertical column of the periodic table are called groups or families, and the horizontal rows of the elements in the periodic table are called periods. So as we run, as we run here, this will be 1, 2, as they are already written here, you can see them clearly. Let me try to make it wider so that it's easy for you to see what I mean here. So we have group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so forth, up to 18. Then we have the periods having period 1, 2, 3, 4, 5, 6, 7. So normally, the periodic table organizes elements by their chemical properties. So we are saying here that the vertical column of the periodic table, which are called groups, have similar properties. So each group contains elements with similar chemical properties. So if you look at these ones, for example, which we are calling them the noble gases, these are the noble gases, the noble gases. They will show the same characteristics. If we look at elements in this group, which is group 1, they are metals, and these ones are very reactive because they only have 1 electron in their outermost energy shell. So notice that groups, for example, groups of elements in group 2, which include beryllium, magnesium, calcium, calcium, strontium, barium, and radium. All these elements are reactive metals, similar with similar abilities to bond with other kinds of atoms. So the metalloids, the metalloids, on the other hand, have properties intermediate between those of metals and non-metals. So these are, in fact, the metalloids. These are the metalloids. What we see here, these are the metalloids. They have intermediate properties between metals and non-metals. Then what we have in this, on your right in green, these are the non-metals. So these are metals, these are metalloids, and these are non-metals. So when we are looking at elements in a period, their physical and chemical properties will change somewhat regularly across the period. It will change across the period, so that as you go down the period, there will be changes. And the reason to why they change down the period is because of the change of size of the atomic structure. So as you go down, the atomic structure becomes bigger, and this will bring about changes. These changes are not very, the ones which are near each other have almost the same similar characteristics, but as you go down the group, they change respectively. So for example, in period 2, the element lithium and beryllium, lithium here and beryllium, which are in group 1 and 2 respectively, are somewhat similar in properties. So these two are similar in properties. These two are similar in properties, but as you progress this way, the properties will change. The properties will change. That is in period. And even also in group, as you move down the group, there will be changes depending on the properties. So, however, the properties are very different from the properties of fluorine. If you took, for example, these two as we saw them, then you try to compare them with fluorine, which is here, you will find that they are totally very different. So the two sets of elements placed below the periodic table that make up what we call the lanthanide and the actinides, this one here, the lanthanide and the actinides, as we saw them, these metal elements fit in the table just after element 59 and element 59. So we are having 50 here, so 57. So they will fit somewhere from element 289, element 89. So, and they are placed below the table to keep the table from being too wide. So, to avoid the table from becoming too wide, that is why they decided to put these ones down. So, they cut this from 50 here, 7 we go to 58, and from 86 we go to 87, and so forth. We go to 87. So the reason is clear, that is to avoid the table from being wide. Some elements are metals, as we have seen. All these are metals, these are metalloids, and some are non-metals. So they have different characteristics. So some of the properties of metals may be familiar with you. For example, we know that metals will always, metals will look shiny, metals will look shiny, metals will look shiny, and apart from being shiny, so metals will look shiny. So metals here are, they are always shiny. They are also malleable, which means we can change them. They are malleable, which means you can hammer them into the structure that you want. They are also ductile. You can make rolls of wires out of them. Those are just but properties of metal. Metals are also known to conduct electricity. Metals are also known to conduct electricity. So this, thus metals, a metal is just an element that is a good electrical conductor and a good heat conductor. So at room temperature, most metals are solids. At room temperature, most metals are solids. When we are talking of room temperature, we are talking about at around 25 degrees Celsius, which is the normal room temperature, or the temperature that we live in. So they have different properties. As we have said here, metals have the following properties: malleability, ability to be hammered into, so these ones can be hammered to shape. 2, they can be rolled into sheets, what we are calling ductile. They are ductile. Because they are ductile, they can be rolled into sheet. Because they can hammer, they can be rolled into sheet. But because they are ductile, we can draw fine wires out of them here. We can draw fine wires. We know the importance of wires. What gives metal this ability is because of their high tensile strength. Which means metals can be stretched or overstretched without it being of any problem. So we say their ability to resist breaking when pulled. This is their ability to resist breaking when pulled. So when you pull them, they will not be easily they will not easily break. This is just by the characteristics of metals. So although all metals conduct electricity well, metals also have very diverse properties. For example, if we take an example of a metal like what here we have mercury. We know it is liquid at room temperature. Yet we said that metals are solids at room temperature, but this one is not following that order, whereas tungsten has the highest melting point. Tungsten has the highest melting point. Of any element. Which means it is one element which has the highest melting point. So metals in group 1 are so soft. Group 1 are so soft. Metals in group 1 are so soft that they can be cut with a knife. So we can cut them with a knife. Yet others are so soft. Yet others, such as chromium, other metals such as chromium are very hard. They may be in the same group, but they are very hard. So some metals such as manganese and bismuth are very brittle. Some are very brittle, which means they can easily break. Brittle, like for example, manganese and bismuth. Manganese and bismuth. Some other metals, these ones are brittle. Some yet others like iron and copper are very malleable and ductile. So others are malleable and ductile, which means we can roll wires out of them, and we can also hammer them to produce sheets. So you can see the varying properties that metals have. Most metals have a silvery or grayish white luster. Most metals have a silvery or grayish white luster. That is, they are normally shiny, but copper and gold are yellow and reddish brown respectively. So copper has a characteristic reddish color and a metallic luster. It is found naturally in mixtures. Pure copper metal will melt at pure copper metal melts at around 1083 degrees Celsius and boils at 2567 degrees Celsius, which means it can hold a great deal of heat. It can be readily drawn into wire or pressed into thin sheets, and because of this it is used in turbine or turbines. So copper conducts electricity with little loss of energy. Also copper remains unchanged in pure dry air at room temperature. So when heated, it reacts with oxygen in air. It can also react with sulfur and other elements in group 17 of the periodic table. The green coating on a piece of copper that comes, so the green coating that you see on copper after it has been exposed to air for some time is nothing but rather a coating of copper. Is a reaction of copper with oxygen. So copper can react with oxygen to form copper oxides, which is the greenish color we see on copper metals. Carbon dioxide and sulfur also react with copper, and it's also essential mineral in the human diet. So you can see how copper as a metal is very important. On the other hand, we have the metalloids. We have the metalloids. The metalloids are found between the metals and non-metals. Let's look at some of the properties of these, some of their properties. We will look at some of their properties. So some elements are non-metals. Some elements are non-metals, while others are metalloids or metalloids. We said metalloids are in between, they have characteristics in between metals and non-metals. So many many non-metals are gases at room temperature. Many non-metals are gases at room temperature. At room temperature, sorry. At room temperature. This includes nitrogen, oxygen, fluorine, and chlorine. For example, nitrogen, fluorine, chlorine. All these will exist in form of gas. One nonmetal bromine exists as a liquid. One nonmetal bromine is a liquid. This is special. One nonmetal bromine is a liquid. So as others are gases, but this one is a liquid at room temperature. The solid nonmetals include carbon. So solid nonmetals include carbon, sulfur, selenium, and even iodine. So all these are solids. So these solids tend to be brittle rather than malleable and ductile, and unlike their counterparts. They have low conductivity. Therefore can be used. Non-metals have low conductivity, which means they do not conduct electricity easily, and they also don't conduct heat easily. So we say they are poor conductors of heat and electricity. They are poor conductors of heat and electricity. So the nonmetals are poor conductors. There are fewer nonmetals than metal. There are fewer nonmetals than metals. So if we are talking about their occurrence, there are less nonmetals. There are less nonmetals. So we will stop there for this video, and we will proceed in the next video to finish up or to sum up.